So far, we have understood linear searching as well as binary searching algorithm, right? In the case of binary searching algorithm, we can only apply it on an array which is either sorted in ascending order or in the descending order. If the values are placed randomly in the array, we can't apply binary search on top of it. And similar to that, in the case of exponential searching algorithm also, the array needs to be sorted perfectly. Otherwise, we will not be able to apply exponential searching algorithm on the array of the values that we have been given. But in the case of binary searching algorithm, what exactly we did? We basically divided the array into two halves based on the mid. Okay, based on the nature of the value we have at the mid, we either went and searched on the left part of the array, or we went and searched on the right part of the array. That's how we eliminated the remaining half. But in the case of exponential search, what we will do is we will make use of this binary search, but first we will find the possible range in the array in which the value could be available. So first we will find the actual range in the array. That means the starting point and ending point in the array where that value could be present. Once we find that range, then we will apply the binary search on that array. Okay, so in the case of exponential searching algorithm, what we do is first we will find the range in which the value could be present. That means we will try to find the starting index for that part of the array and ending part of that array. Using these two values, we will try to apply the binary searching algorithm. So the exponential searching algorithm is divided into two steps. One step is to find the starting and ending position in which the value could be present. As part of the second step, using the starting index and ending index, then we will apply on that binary search to find the value that user has given. Okay, so two steps. One is to find the range and the second is to find the apply the binary search and find the exact position at which the value is present. Now let me try to explain the same thing using a simple example so that you have a better clarity. Here the values that we have got are minus 71, minus 51, 11, 19, 27, 57 and 76. Totally we have 7 values in the array. Now let's say the value that user wants to search in this array is, let's say 57 is the value that user has passed as part of the searching implementation. Now what we will do, first step, we need to find the range in which the value could be present. So for finding that range, what we do is we will start with index 1. Okay, why we start with index 1, that I'll explain it in 2 minutes so that you will have that clarity. Now let's say I will call this variable as start index. Okay, for that range. The start index is 1. Now what we will do is we will compare the values at these indexes with the value 57. Here we have the value of minus 51 and the value that user wants is 57. So obviously 57 is larger than minus 51. So it could be on the right side of the array. To find the right bound of the array, what we will do, we will again move on to the next start index. We will get the new start index by multiplying the old start index into 2. That means start index is 1 right now. We will multiply it with 2. So the new start index will be index 2. So we will reach the index 2 again. At index 2 we have a value of 11. But the value that user has passed is 57. Obviously 57 is larger than 11. So it could be on the right side. So to find again, we will again update the start index with start index into 2. Now the value will be 2 into 2, which is 4. So we will move on to the index 4. At index 4 we have 27. Obviously 57 is larger, right? It is further on the right side. Now again what we will do for that, we will again update the start index equal to start index into 2. That is, we will get the index of 8. Now here the index of 8 is not available in the array. So the value is present from previous start value, which is nothing but the start index. That is, previous value was 4. So it could be anywhere from 4 till all the values in the array. Is it clear? So now the latest start index that we have got is 8, which is not present in the array. That means the possible range for the value in the array could be whatever the previous index that we got, 4, and the last index in the array. That means whatever the remaining values in the array, that could be the actual range in which the value could be present. So what we will do, we will apply binary search from index 4 to the remaining value. So for applying binary search, the start index is the previous start index, that is 4, and end index will be either length of the array or this one, the new start index that we have got. Okay, now what we will do, we will simply go and apply binary search on this and we will get the value that we want. So how we will get, as part of the binary search, again we will calculate the middle index, and again we will compare if the value of the middle index is same with the value that user has passed. If not, we will either move on to the left part of the array or move on to the right part of the array. So our programmatic implementation basically should give index 5. Okay, so this is the algorithm behind exponential searching algorithm. Once again, let's try to revise. There are only 2 steps. Unlike binary searching algorithm, first we will try to find the range in which the value could be present, and once we find that range, we will basically apply the binary searching algorithm on top of it. Okay, that's how we will find the value that user has looking for. Okay, and the important thing is it can only applied on an array that is sorted. Okay, now that we have understood this, let's go ahead and let's try to write the pseudocode for that. Okay, so as part of the exponential searching algorithm, I mentioned that it is divided into 2 steps. One is find the range, and second part is apply binary search on it. Okay, this binary search we have already implemented on the previous implementation, right? So I will be reusing the same implementation with a slight modification, so that I will explain it anyway while implementing it. Now first step is to find the range. For that, anyway, for implementing the exponential search, I will be writing a exponential search function which will basically take the array and the value that user has passed. Once we find this, to find the range, we started with index 1 always. Okay, I mentioned that I will explain it later on why we are starting with index 1, right? Why we are starting with index 1 is, in the later operation, to find the perfect range, we are updating with start index with start index into 2, right? If we start with index 0, no matter how many times we multiply, we basically have index 0 itself. Okay, just to eliminate that case, we are starting with index 1 always. Okay, for that, let's say I'm going to define a variable called start index and I will initialize it with 1. Now, as long as first, for finding that range, what I am doing, I will be using a single variable itself for finding the range. How? I will explain now. While whatever the start index, if it is not overflowing the length of the array, that means it is always less than or equal to length of the array, and whatever the value that is present at this index, that means array of start index, if this value is less than whatever the value that user has passed, what we did, we actually updated the start index with start index into 2. If this is the case, we will update the start index equal to start index into 2. Okay, once we complete this loop, right, whatever the value we have in the start index will contain the end index in the array, right? So using this single variable itself, we can find the minimum and maximum for the binary search implementation. How we will get? Min will be this start index divided by 2, and the maximum index will be whatever the value we have in the start index itself. Because we are multiplying by 2, in the previous iteration, we have obviously searched for the value at start index by 2, right? So we couldn't find that value. So from that index, whatever the start index we have right now could be the range for the value that user has passed. So that's why we are getting the min and maximum values. Now using these min and maximum values, we can simply apply binary searching algorithm on the array, starting with min index and max index with the value that user has passed. Okay, this binary search will obviously will return the index of the value that user passed if it is available inside the array. If it is not present, obviously it will return -1, right? So whatever the value this returns, we can simply return that so that our function implementation will be completed. This is how the pseudocode for the exponential searching algorithm will look like. Let's try to calculate the time complexity and space complexity. So to calculate the time complexity, let's calculate in best case as well as worst case. Okay, so when will the best case of exponential searching algorithm will appear? So anyway, as part of the implementation, first we are trying to find the range, right? As part of the range calculation, what if the value that user wants is available at index 1 itself, right? Then we will obviously will not execute the while loop at all. We will not go into the while loop and we will not execute itself. For index 1 itself, we will go out of this loop. We will apply the binary search on the array from 0 index and 1 index. So obviously this binary search will execute only once. So the overall time complexity when we have the value that user has passed at index 1 itself, then we are running the loop only once, even to search the value using the binary search. So in that case, the time complexity will be order of 1. But in the worst case, what could happen? Whatever the value that we are searching could be the largest value or might not be available inside the array. In that case, to find this range itself, in each and every step, we are updating the start index with start index into 2. So in that case, similar to binary search calculation, this logic will get executed for log n number of times. After that, if you observe this binary search implementation, right, we are not applying the binary search on the entire array. We have certain range which is less than the length of the array. So obviously in that case, the binary searching algorithm, the time complexity will obviously be less than log n only, because we are only applying it on a certain range. As a result, if we combine these two steps time complexity, the overall worst case time complexity will be order of log n. Okay, to calculate the space complexity, even in the best case or even in the worst case, if you observe the implementation, we are taking the help of a single variable which is start index. Using this start index itself, we are able to calculate the min and max for the binary search call that we are going to make. So obviously this variable will take constant amount of memory, and this variable itself is being reused for updating so that we can find the largest index in the array in the potential search range. As a result, find range logic will take constant amount of memory. We already know the binary searching implementation will take constant amount of memory, be it best case or worst case. If you don't know how to calculate, you can go on to binary searching implementation and you can find out the time complexity and space complexity there. We will not be calculating the same for binary searching algorithm. As a result, be it best case or be it worst case, the space complexity will still remain constant plus constant, which is nothing but order of 1 only. That is how we calculate the time complexity and space complexity for exponential search algorithm. Okay, it is exactly same as binary searching algorithm. Okay.